hello, welcome to another week of science. So we this week are starting our earth science portion because, I don't know, earthquakes, volcanoes are just more interesting. So we are going to start off this week with looking at this idea of continental drift and how continents can move away from each other. Then next week we're going to go into our plate boundaries, plate tectonics. And then we'll spend 2 weeks looking at earthquakes and volcanoes. So I hope you look forward to that. Without further ado, continental drift. Oh yeah, and you can say that you can watch Ice Age for science. I'm not forcing you to, but if you feel like you need an excuse to watch Ice Age, you can say it's for science. So welcome to Earth Science. This is our first lesson of Earth Science. And today we're just going to talk about continental drift and the layers of the Earth. We won't get too in-depth today. We'll treat this more as an introduction. So we have three key concepts today that scientists debated how to interpret the shapes and positions of the Earth's continents, that technology helps scientists make inferences about the different layers of the Earth, and that studies of the ocean floor reveal where new rock is made. Okay, so first off, let's look at the shapes and position of continents. So with the exception of events such as earthquakes, volcanic eruptions, and landslides, most of Earth's surface appears to remain relatively unchanged during the course of a human lifetime. So we're just talking about one individual human's lifetime. On a geologic timescale, however, Earth's surface has changed dramatically. So until the mid-1900s, most geologists thought the locations of the continents and oceans were determined when the Earth first formed. And this idea was called fixism. So that everything was fixed in its place, nothing moved. Now, what then happened was this guy named Alfred Wegener came up with the continental drift hypothesis. So he created a new map of the Earth by fitting the continents together. He basically looked at all the continents and went, hey, if I push these together, they fit almost like a jigsaw puzzle. And he proposed that 200 million years ago, all of the continents were connected in a single supercontinent called Pangaea. He hypothesized that over time, the continents slowly moved apart until they reached their current positions. So here's Pangaea. We've got North America, South America, Africa, Antarctica, Australia, Asia, and still another part of Asia and Europe here. So basically the idea was if we push these all together, they fit together quite well, given that there could have been other erosion, etc., leading to some of the shape. So maybe at one point there was just one large continent. So this was originally rejected. People just were saying, hey, no, you can't explain how these continents could move, so we're going to stick with what we were saying before. And it was revisited decades later, and discoveries about the ocean floor provided information that supported the idea that continents move. So the Earth is about 12,700 kilometers in diameter, and so there was no tool that could probe deep enough to see the Earth's inner layers. These layers are going to help clarify how continents can move, and there was just no way to do so. However, scientists study the waves that travel through the interior during earthquakes to gather information about Earth's layers. So from those studies, what we were able to figure out is 4 main layers of the Earth. We've got the crust, which is the outside layer here, and it's a thin layer of solid rock surrounding the Earth. Then we have the mantle, this orange layer here. It's made up of the upper and lower mantle. It's more solid. Then we have the outer core. It's the only layer that is liquid. And the inner core is the deepest layer and is also the hottest at more than 5,000 degrees Celsius. So using sonar, scientists discovered mountain ranges and deep valleys on the ocean floor. And we discovered that there's these things called mid-ocean ridges and trenches, and that earthquakes and volcanic eruptions are common along these mid-ocean ridges. So we have these ocean rocks that are much younger than land rocks, and the ocean floor near the mid-ocean ridges is much younger than the ocean floor farther away from the ridges. And we see what's called seafloor spreading. So it's this process of magma rising to the surface as mid-ocean ridges form at the mid-ocean ridges to form new ocean crust. So we've got these layers. We have these older layers here. Here's a mid-ocean ridge. And we see that we get some of the warmer layers coming up through the ridges and spreading out further. So this is the seafloor spreading. And you can imagine as we get this to spread, we could see continents starting to move apart. So that is it for this lesson. You have a project that is attached to the email today where you're going to kind of focus more on the idea of continental drift and Pangea. So I hope you enjoy that. We will be continuing along with looking at plate boundaries and plate tectonics next week.